Good morning again. Here we go. This is a study guide cool down for 2.2. Question is, an account grows at an annual interest rate of R. So it grows by a factor of x equals 1 plus R each year. The function a of x gives the amount in the account after 4 years when the growth factor is x. And then 3 questions follow afterward. The first question is, what is the total amount in the account if the interest rate for the account is 3% each year? Okay, so let's begin by actually writing down our equation here. I remember in the original video, I probably didn't fit it. So this, if I had enough space, would take up 1 line, but I might take up 2, just in case you're wondering, why is he writing on a second line? There's quite a bit to write here. So we have 800x to the 4th plus 350x to the 3rd plus 500x squared plus 600x. All right, there you go. Fix this equal sign. So I'd actually like to first talk about that substitution, because it says x is going to be equal to 1 plus r. So each of these x's is equal to 1 plus r. So they gave us the value of r, which is the rate, to be 3%. Now, 3% as a decimal, take my word for it, is 0.03. Okay, I'll do a quick calculation down here. The decimal's here. Move it twice to the left. And you're going to end up with 0.03. If I move it back 1, 2, you will see it lands back in the original spot. Just a quick reminder on how to turn a percent into a decimal. Okay, that's what we have up there. So now I can actually add 1 plus 0.03 and I get 1.03. There you go. The reason I'm bringing that up is because I'd like to calculate the value of x as a number rather than substitute 1 plus r and do this every time. Now I can substitute 1.03 in place of each of these x values, and I will do that on the next line. So now instead of a of x, we're actually going to define x by its actual numerical value of 1.03. Okay, this does not mean a times 1.03. I'd like to remind you of that. It means a in terms of 1.03. I am intentionally going to leave the x values unsubstituted right now so that I can show you how to do that. See what I told you? It's going to be really cramped. It's funny how these are the ones that get cramped. Okay, let's go ahead and make our substitutions. Let me bring on some pink. I haven't seen that in a while. Okay, so 1.03 into each of the spots where x is located. Now, these values are really difficult to calculate by hand, so I would highly suggest that you have a calculator handy. You can simply ask your phone or type it in, whatever preference you have. But I'm actually not going to be doing that on the video so that I can use the time wisely here. So you can push 1.03 times 1.03 times 1.03 times 1.03 if you wish to do so. Or on your calculator, you can use the power keys to actually put that. So 1.03 to the fourth power, you just type it in that order and you'll be good to go. All right, so the values I'm about to put in is because I already did that. Okay. So the first one was 1.1255. Okay. Next one. That's 350. And 1.03 to the third power is 1.0927. 1.03 to the second power gave me 1.0609. And the last one is simply itself, 1.03 to the first power, it's 1.03. Okay, so next you have to calculate each of these four terms separately by multiplying the constant outside of the parentheses to the constant inside of the parentheses next to it. So we're gonna multiply these two values, place it here. We're gonna multiply these two values, place it here. These two, place it down here. These two, place it down here. Okay, let me change colors too, so I know, because when we start seeing things, it's really hard to tell what's what. So the product of 800 times 1.1255 will give us 900.4. Okay, we'll put a little check, or actually just put this little sign here saying, okay, I already got that one down. The product of these two numbers gives me 382.445. And I know we're talking about money, but you're probably thinking like, wait, when are you gonna get 0.445 of a dollar? It actually, when you go deeper into it, you actually can carry money in that way, but it's neither here nor there, just in case you're wondering. Then these two right here, which I will signify with red, give me 530.45. And the last one there, which I would just do with what I have here, purple. Oh, that's right, I never got the green back. 600 times 1.03 is 618. Now we have acquired the four products, which I have color coded, and now we're going to sum these four values to get our final answer here. I'm not going to round here. I'm actually going to leave it as $2,431 and 0.295 cents. I'm just going to leave it like that. But if you did want to round, you could get 2,431 and 30 cents. That'd be fine. Or if you really wanted to just round to the nearest dollar, you could do it 2,431. Any way you wish to think of it and get near the answer and approximate, that's fine. So even if you had an answer of like 2430 because you made another like rounding over here, that's fine. Something like this though wouldn't work. Something extremely large like 10,000, you're way off the mark. So if you're within a dollar or a few cents, it's not a big deal to me, it really isn't. But if you're off by like thousands of dollars, then it's obviously wrong. Okay, so that's the calculation you go through when someone gives you the rate to a bank account and you submit amounts of money into that bank account one year after the other, after the other, after the other. Which brings us to our next point here, because the next question asks us, what's the most recent deposit they made and what's the first deposit they made? So let's do that. Okay, what did it ask? There was X amount of dollars placed into the account at the beginning. Okay, so I will actually not only answer at the beginning, but I'd also like to answer at the end. So what I'm gonna do here is I'm actually gonna erase the calculations, okay? Luckily it's a video, so me erasing it's not permanent, you can always rewind. But so that I can have some space to write. Okay, so the first deposit will always be located if your equation is in descending order at the beginning. but to be honest, it's always located next to the highest valued exponent in the equation. You will notice the exponents are 1, 2, 3, 4. So 4 is the largest. That means that's where the account has been the longest. Where the money has been the longest, sorry, not the account. Where the money, I'll put a dollar sign there. We all know this one. Where the money has been the longest. And I'm gonna be specific here actually, for 4 years. So there has been $800 that was deposited 4 years ago. Is it $800 now? No, it's larger. That's what this is all about. It's about growing your money. Okay, so if this is the oldest money in the account because it's been there for 4 years, by definition, that would mean that this last term would be the most recent deposit. There you go. The most recent deposit of $600. There you go. Now, if you wanted to make another deposit, that would actually change the equation here. Let's say you deposited another amount, and I think the problem was specific that after 5 years, $200 is added to the account, and now you need to write a whole new equation. Okay, so we have an account that has been around for 4 years. The first year we deposited 800. The second year we deposited 350, 500, and 600. Now we're going to create an equation to reflect a deposit a 5th year into the account. So no money has been pulled out, okay? So we still have this money in the bank growing due to interest. So this right here, let's say we go into the 5th year and we make a new deposit. This would then state that this $800 is now in there for 5 years because now it's the 5th year of this account existing. This $350, which was deposited 3 years ago, now that it's aged 1 year, in the expression, we can age the exponent by 1. Therefore, we'll go up by 1. Now it's 4 years old, that particular deposit. We'll do the same for the other two. Sorry, this is a 3. Now the most recent deposit, which was, what was it, $200, will be reflected here, and I like to circle it as well. Now this is the most newest addition to the money family in the account. All right, thank you so much. Good luck.